This video is going to start our reviewing for our unit test. We've already covered all the material that we need for this unit, and this video is going to kind of go over some of the more challenging topics that we've covered that you might need a little more practice in. So to go way back to the very beginning, we started talking about function notation. Right? We use this function notation so that we can work with more than one equation at a time. Instead of everyone being y equals, now we've got an f and we've got a g, so we know which equation we want to work with. Okay, so the first example, we want to find f of 3. The only difference between f of 3 and f of x is now instead of x, I have a 3, which means I'm going to go in my equation, and instead of x, I'm going to put a 3. So f of 3 becomes 3 times 3 minus 2. Well, 3 times 3 is 9, and 9 minus 2 is 7. So f of 3 equals 7. G of 1. Now I'm going to come to g of 1, and instead of x, I'm going to replace it with a 1. So I've got 1 squared plus 1. 1 squared is 1. 1 plus 1 is 2. So g of 1 is 2. F of x plus 2. Very similar to f of 3, but now instead of just one number, I have this little binomial that I'm going to plug in. So for every x, I'm going to replace it with x plus 2. So that means it becomes 3 times x plus 2 minus 2. Whenever you have a number out front of your parentheses, you have to distribute it. 3 times x is x. 3 times 2 is 6. And then I'm going to bring over my minus 2. My only like terms are the positive 6 and the negative 2. 6 and negative 2 gives me 4. So f of x plus 2 is 3x plus 4. And the last one, I've got f of 6 plus g of negative 2. Alright, so I'm going to find f of 6, get a number, then find g of negative 2 and get a number, and then add them together. So to start with f of 6, alright, I'm going to replace the x with 6, so I've got 3 times 6 minus 2. 3 times 6 is 18. 18 minus 2 is 16. Okay, then over here I got g of negative 2. So I'm going to plug in negative 2 squared plus 1. Negative 2 squared is the same as negative 2 times negative 2, which is a positive 4. And 4 plus 1 is 5. 16 plus 5, 21. So f of 6 plus g of negative 2 is 21. Okay, remember, when you're plugging into x squared, it's always going to be positive unless your equation has a negative out front of your x squared. Okay, that's the only time that it's going to be negative. Other than that, everything squared, it has to be a positive. We also looked at transforming a graph, right? Now this goes back to using those two letters h and k, right? So the way you can remember it is it's always going to have x minus h in parentheses and a plus k on the outside. That h is our horizontal, left and right, translation, sliding it left and right. K is our vertical. Okay, the trickiest part to remember is that the horizontal h is always the opposite sign. Always, always, always. Okay, so I want to know, how is f of x minus 2 minus 5 transformed from f of x? Alright, so I've got an h. My h is a positive 2. And I've got a k. My k is a negative 5. K always keeps the same sign. Alright, so a positive 2 in a horizontal direction is right 2. So I took my graph f of x and I've gone right 2. And a negative 5 in a vertical direction is down 5. So we've gone right 2, down 5. Right 2, down 5. Okay? The other type of problem you might see with this h and k and transforming an f of x is this type of problem where you have f of x is graph below, so you're given a graph, and you want to sketch a graph of f of x minus 3. Or you might see it as a multiple choice question where it says which of the following is f of x minus 3. So you got to think back. This 3 is on the outside, Okay, so it's definitely a K, so it's a vertical, it keeps the same sign. So my K is, oops, a -3, right? -3 in a vertical direction is down 3. So all I'm going to do is take my graph and I'm going to sketch it as if it were moved down 3. Okay, the easiest way to do that is to try and find some, important points on your graph, right? So this one looks like I got a point right here. So I'm going to go 1, 2, 3. Put a point. All right, this one is an important, like a low part, so I'm going to attempt to make that one go down 3, so right in there. And then another one that looks like it's a good point is up here, so I'm going to go 1, 2, 3. Now I'm just going to follow the curve and try to see how many of these I can hit. I'm going to try and sketch this graph. It's a rough sketch. Okay, so all I did was take my red graph and move it down 3 to get my green graph. We also talked about distance and midpoint, okay, using formulas. These are very common formulas that we're going to continue to use throughout the year, but they're kind of easy to get messed up, right? You got to make sure you keep your x's in line, your y's in line, have the right subtraction or addition based on the formula. Okay, so the distance formula, you got to memorize it. You got the distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, what's important to remember is that x2 and y2 is one of your endpoints. x1 and y1 is the other endpoint. So whatever endpoint you start with in x, you have to start with in y. Okay, so I want to find the distance between m and r. Right, so if I said m is my x1, y1, r is my x2, y2, I'm just going to plug those in. So my distance equals the square root of x2, 2, minus x1, 2, squared, plus y2, 2, minus y1, 1, squared. 2 minus 2 is 0. 0 squared is 0, so this whole side goes away, cancels out. 2 minus 1 is 1, so distance equals the square root of 1. Well, 1 is a perfect square, so my distance is 1. Works out nicely. The midpoint formula, we got the midpoint equals, we got big parentheses with x1 plus x2 divided by 2, y1 plus y2 divided by 2. Right? I'm finding the average of my x's and the average of my y's. Right? I'm finding that middle point. Now remember, distance is a formula you plug in and you just get a number. Midpoint is something you plug in and you get another coordinate point because you're finding a point that's halfway between your two endpoints. So we've got D, which we'll say is x1, y1, and E, x2, y2. Okay, now you don't really have to do this with midpoint because you're adding. And adding doesn't matter what the order is, so it really doesn't matter as long as you add your x's and you add your y's. But just for the formula purpose, I've got x1, y1, x2, y2. So on my left hand, the x side, I add x1, which is 2, and x2, which is 4. I'm going to divide those by 2. y1 is 8. And y2 is -8. And I'm going to divide those by 2. 2 plus 4 is 6. Alright, so we'll come over here. So I got 6 divided by 2. 8 plus -8 is 0. So I got 0 divided by 2. 6 divided by 2 is 3. 0 divided by anything is 0. So my midpoint is at 3, 0. That's the point that's halfway between D and E. Another thing we looked at is analyzing graphs. Okay, so that's finding the domain, the range, roots. Okay, telling the intervals it's increasing, decreasing, and constant. Okay, now roots. Remember, roots is one of 4 words. Okay, so you may hear roots, or you may hear x-intercept, or zeros, or solutions. Okay, they all mean the same thing. So if I ask you to find the roots and I give you a graph, you're just looking for the x-intercepts. Okay, if I ask you for the zeros, you're looking for the solution to your equation, right, your function. So I want to find the domain, range, and roots, and then we'll talk about the increasing, decreasing, and constant. Right now, if I look at the domain, remember, domain is where your graph goes in terms of x. Right? So this arrow, oh, lost my cursor. This arrow is pointing down, which tells me it's going to go left forever. Right? So that means that I've got some, my graph keeps going left and use all the negative x values. If I keep going this way, go up, come back down, keep going to the right, keep going to the right, and then I have this arrow says it's going to the right forever. So that means I'm coming all the way from the negative forever to the positive forever, and we call that forever infinity. So my domain is negative infinity to infinity. Okay, that's interval notation. You could also say you want all the x's that are an element of all real numbers. Okay, we use all of the x values. All right, range is the y values. Okay, domain is x, range is y. So if I always start from the bottom, start from the negatives. This arrow over here in the left corner tells me it's going to go down forever. So that means I'm coming from negative infinity. Okay, I'm coming from the bottom. Okay, coming up, and then I come up here, which looks like, we'll say this is at a 1. All right, and then my not so great spaced out, we'll say this is 2. Okay, this comes up and starts to go back down. So it looks like right now I'm stopping at 1. But then when I come over here, I go up past 1 to what we're going to say is 2. And then I don't go anymore because it stays flat right here and just goes to the right. So that means I'm coming from negative infinity all the way up. I have y values everywhere, and then I stop at 2. Okay, and I'm going to put a bracket around 2 because I have y values right here. Okay, my graph is included at 2. Oh, that was not even close to a straight line. Okay, so I am putting a bracket to include it because this is like greater than or equal to, right, or less than or equal to. Okay, so it's the or equal to, so I'm putting a bracket. All right, so that's interval notation. Another way you may see it is that I want all the x values that are below 2 or equal to 2, hence why we're using the bracket. All right, the roots of the function, also the solution, so we could say x equals, right, and I'm just going to list out all of my x-intercepts, right, I'm going to do a little estimating. So I've got 1, 2, 3, 4, maybe like 4 1/4. Okay, so we'll say negative 4.25. Okay, the next one just past 1, so maybe like 1.2, negative 1.2. And then the next one is just at a positive 3. Now guessing on that one. So I have 3 solutions, or 3 roots, and it's at negative 4.25, negative 1.2, and 3. All right, now I want to talk about increasing, decreasing, and constant. Okay, increasing, decreasing, constant. It's doing all 3 of those here. I think the easiest one's probably the constant, right? And that is this part right over here. Here's my constant area. Okay, so from here on forever this way, because of that arrow, it's going to be constant, right? So that means it's constant from 1, 2, 3, 4 to infinity. Okay, remember your increasing, decreasing is always using the x values. Right, the next one I'd say the easiest is probably decreasing. Right, and it's decreasing from right here to this other green dot down here. Right, so from negative 1, 2, 3 to positive 1. So negative 3 to positive 1. And then it's increasing in 2 different places. All right, we'll draw increasing out here. I'm going to start left to right. Okay, so from negative infinity to negative 3. Okay, it's increasing. Then it jumps and comes over here from 1 to positive 4. Remember our and, we use the union, so then we jump from 1 to 4. Remember, your increasing and decreasing constant needs to make up your entire domain. So in all 3 of those, we include all real numbers. And that's all the time we have for this video.